Hi guys, this is the second part of exponential functions that we're going to talk about. We want to learn how to uh, write exponential functions, either as if they're growth or if it represents a decay, mainly focusing on word problems, looking at the graphs, and so on. So if you take a look, I've got two formulas here that we're going to use. The one with the plus sign is going to be a exponential growth function. And that means that when you read a word problem, something within that word problem is going to tell you that values or the numbers are increasing. They are going up, so increasing. And it makes sense because there's a plus sign in that problem. Over here we have a minus sign. This is going to be exponential decay. And of course, with decay, you're looking for something that tells you it's decreasing or losing value, or declining, going down, something like that. So decreasing. But you have to read the word problem to determine whether the value or the amount, whatever it's talking about, is going up or down. So the formulas are exactly the same with the exception of the plus or the minus. All of the values represent the same thing. The A is the initial amount. The initial amount. Initial just means the starting. Whatever you started out with, the starting amount. The T represents time. And the R is the rate of the increase or decrease. Usually this is written as a percentage. All right, so the first thing that we're going to do is we're going to read this problem. It says a new SUV, and it's talking about this SUV over here. A new SUV depreciates in value each year by a factor of 15%. That first sentence tells you whether or not it will be increasing or decreasing because this word right here tells which it is. So that's a clue. Now, it does not say decreasing, it does not say increasing, but you're going to have to read those clues to be able to determine if it's going up or down. In this case, depreciates, that means it's losing its value, okay? So this is going down in value by a factor of 15%. This 15% is our rate in which it's decreasing. It says draw a graph of the SUV's value for the first 20 years after the initial purchase. So we've got a grid down here that we're going to work with. And then over here, I've got another problem that we're going to look at. But let's start by first writing our function. It's not increasing, it's decreasing, so we're going to use the minus sign. So we'll write A of t equals the initial value. Well, it didn't tell me in this, but it tells me in the image here. It says all new, only $30,000. So $30,000 is the starting price. And in parentheses, we'll have 1 minus the rate. So 1 minus 15%. And all of that raised to the t power, because each year it's different. Now, it says draw the graph for the first 20 years. It doesn't say tell me the value at 20 years. So I don't want to plug 20 in here because I want that to be able to change. I want 1 year, what happens 2 years later, 3 years later, and so on. Now let's simplify this. If we take 15% as a decimal, that would be 0.15, and 1 minus 0.15 is 0.85. So our A of t simplified formula is 30,000 times 0.85 to the t power. Now you could just plug in values and work them out by hand, but no one really wants to do that. So take your calculator, go to y equals, and type in your formula, 30,000 times 0.85 raised. Now, we don't have a t, but we're going to put x because that's our variable. That's what's changing. So x is the t value. Now, we can graph it. Let me make sure that my window is set normal. And notice, nothing's there. Well, that's because the amount, when you look at your graph, the amount that this SUV started at was 30,000, and my graph's only going to 10. So I need at least my y-axis to go up to 30,000, and also the time. The time, how many years? Well, that's on my x-axis, and I need it to go to at least 20. So I'm going to go to Window, and I want to change this. I don't care about negative values of time. We don't care, but I'm going to leave it at -1 just so I can see a little bit past. And my x max, I'm going to just go out to 30 just so I can see past where I need to be. I am going to count by ones. The y minimum, I don't need a negative amount of money. Like the y-axis is how much the value of the SUV is. So I don't need negative numbers, but I'm going to just leave it at -1 to leave like a little barrier there, a little buffer. And then the maximum, well, 30,000 is the starting price. I'm going to go just slightly above so that my window, I can see it nicely. So I'm going to say 35,000. And then graph. Now, there is our function. Okay, and we can tell that this is a decreasing function. It's a decay. So let's go in and graph some points. Well, we know before anything starts, before 1 year has passed, the value of the SUV is 30,000. So this is your time, okay? Your x that we plugged in, this is our time. If you want to write time out here, that's fine. And this is the value. At 0 years, brand new, it is 30,000. Now the rest of it you just plug in, or you can go use your table. So I'm going to do second table, and I'm going to go up to 0. All right, at 1 we're at 25.5. Notice the scale here. If this is 10,000, then we had to count 2, 4, 6, 8, and that made 10. So each block is worth 2,000, so make sure that you count correctly. We're looking for 25,000, so this would be 22, 4, 5 would be right in the middle, but it's almost, because it's 25.5, it's almost up one more. So make sure you're on first year. It's halfway between, approximately. Now you don't have to get every single year because that would be a lot of dots here, but it would be nice if you did. I don't want to do that in this video because that would make the video really, really long. So I'm going to go ahead and go to year 5. Year 5 says 13,300. So I'm going to go up. Here's 10,000. 12, 13 would be here. It's just slightly above. It's not even halfway above, so just slightly above. Okay, I'm going to go to year 7 and see what happens. Year 7 is 9,617. 9,617. Here's 10,000. 9,600, it's going to be close to the 3/4 of the way in that box, so above half, because half would be 9,000, and then almost to the next line. Okay, let's go to 10. 5906, 5,906, 2, 4, 6. 5 is here, and it's almost right on 6 because it's 59. Okay, let's go to 12 or 13. It doesn't matter. I'm going to do 13. It's 36. 36,000. So at 13, I'm at 36. 2, 3 is halfway, and 36 is about there. Now let's look at 15. 26. 2,600. 2,000. And 600 would be almost to the 3,000, or halfway between where that and the 3,000 would be. And let's go to 17 or 18, it doesn't matter. So 17 years later, we're at 1893. 1893, so like almost right on the line. And at 20, we'll go ahead and do 20, 11,000, or I'm sorry, 1,162. At 20, it's 1,100, so we're about there. All right, and I'm going to go back and grab one more here, but so I can, there's a big gap in there, so I'm going to go ahead and get, let's get year 3. Year 3. 18,400. 18,424. This would be 18,400. It's close to getting halfway up to 19,000 there. All right. So now you can see the shape of the graph. You can see it declining over time. And all we're going to do is we're going to sketch the graph. Okay, and there you have it. Now you've graphed it. Now, this asks you to predict when the value of the car will fall below $6,000. And it says give your answer in a whole number of years. Well, $6,000, 2, 4, 6, that would be where my graph crosses this line right here. And remember, this point was like 59, and if you don't remember, you could look back on there, but that would be the point that you're looking at. So after 10 years, or the car will fall below $6,000 approximately 10 years after you purchase it. So after 10 years. If you just said 10 years, that would be fine too. Somewhere around 10 years, that's your appropriate answer. All right, so let's look at another problem.